Let's go to LeetCode 623. Add one row to tree. For this question, it gives us a binary tree and also integer value and integer depth. It let us to add one row in the depth. For example, if we want to add the depth 2, right? So he said that the first layer is depth 1, right? And originally this is depth 2. So we want to add one row to here, right? To have the new row to be depth 2. And for this kind of tree node, to have our value 1. And have this tree node, it's left pointing to this depth 1's left, and this one's right, pointing to this depth one's right. So we add one row here, right? So, and also it said that if the depth equals 1, right, that means we need to add another row here, value here, right? And then let the this kind of row, this kind of tree node, its left child pointing to original root. So what we're thinking about is that for this special depth equals 1, right? And we can use some kind of dummy tree node, right? And we call tree node, sorry, dummy equals new tree node minus 1, right? Then we'll have dummy dot next, not next, left equals root, right? Then we have some function, some method in a dummy, right? And in the end, we just return dummy dot left. So doing like this is like pretty much like the technique in linked list. We have a dummy node, and but we just do a dummy tree node here, right? So that we can treat the depth 1 the same as the other layer. So basically what we're thinking about, we add one row to the tree. There are two approaches. One is using BFS, right? So if we, for every layer, we have the depth decreased by 1. BFS do layer by layer. And if we have depth already decreased to 1, that means this is the layer we need to insert the child, right? The value as this kind of charts, and we then have this kind of created two new tree node for this kind of nodes, right? And then have these tree nodes pointing to this nodes left, and have this node pointing to the new nodes. And also it's right pointing to the new nodes, and these new nodes are not a new right pointing to original right. And also we can do DFS, right? DFS is that we the termination condition is that if the depth equals to 1, right? Then also we do the insert operations, and then we trying to check, right? The other things that we DFS is that if this termination condition is that depth equals 1, otherwise we just check if this kind of is not 1, then check it's left. If it is not null, we DFS left. The right is not null, we DFS the right, right? So we iterate the tree. The time complexity will be O(n). So let's write both BFS and DFS solutions. For example, BFS, right? BFS, we need to have this dummy node and also value in the depths. So let's have private void BFS and tree node, and we need the value and the int depths. So for BFS is that we need to have a queue, right? Tree node and queue equals new array like, and we need to have queue offer this kind of node. So we need to write it for the while, right? While this queue is not empty. We need to do BFS by layer. So we need to have the size equals q dot size. And we'll say for int I equals to 0 and smaller than size I plus plus. And after this for loop, we'll have depth decrease by 1, right? So what we do is that we have tree node parent equals q dot full. And we'll say if for depth equals 1, right? Equals 1, then that is we find this node, right? This node. Then we need to do the insertion operations. So what we need is that we are create a new tree node, left node equals new tree node value, right? And also have a tree node right, new right equals new tree node value, and we'll have current left node dot left equals current dot left, right? And current dot left equals L node, and right node dot right equals current dot right, and the current dot right equals right node. Right? Actually, for if we the depth is already 1, right? We don't need to continue the BFS anymore, right? If we already finished the for loop, right? So actually we'll say if depth smaller than 1, right? We can terminate, right? Break. So we can have those kind of conditions to terminate earlier, right? So and what's the else that is just to do directly in queue, right? So I say if current dot left and equal to now, we have queue offer current dot left, and say if current dot right and equal to now, I have queue offer current dot right. Okay. We can also change this code to Python. So what we do is that we also need to have a dummy, right? So we have for example, dummy equals tree node minus 1, right? And we'll have dummy dot left equals root, and then we'll have a BFS, right? So if we need to have BFS, we'll have defined the BFS. BFS. So we'll have an tree node, right? Node optional. And we need to have a value int depth int. And so what we do is that BFS is this kind of root value, and that's in the end I'll just return. This is not root, should be dummy, right? Because we already have a dummy here. Dummy dot left, right? So BFS is that we need to have a Q, right? Q. Q equals DQE. So for this Q, we put a node into it. So what we do is that while Q and size equals length Q, and we'll have for right? For we can use the underscore in range size. We'll have current equals Q dot pull pop left. Pop left. There is some compilation errors in range size for this one. Q equals deck node while Q size equals this for that's right. And if depth equals to one, so one, then we'll have L node equals tree node value, and right node equal tree node value, and we'll have L node dot left equals current dot left, and right node dot right equals new node, new right node is current dot right, and we'll have current dot left equals L node, and we'll have current dot right equals right node, right? So this is insertion, right? Then we'll have else. That's what we do is that if current dot left, then we'll have Q append. current dot left. And we'll say if current dot right is not null, right? So we'll tell Q append current dot right. So after this for loop, we'll have for each these steps, we have steps minus decreased by 1, right? Syntax. There is comma expected. So this is node comma value. We should have this, right? So this is a Python code. And also we can write DFS, right? So DFS, we also need the dummy, right? DFS. And so the difference is that instead of using the queue, right? Our termination condition is that we have if depth equals 1, right? So what we do is we insertion, right? So we'll have tree node left node equals new tree node value, and tree node right node equals new tree node value, and we'll have this dot left equals node dot left, right? And we'll have right node dot right equals node dot right. And we'll have node dot left equals new left node. And we'll have node dot right equals new right node, right? So this is a termination condition. And we'll have if node dot left down equal to none, right? Then we DFS node dot left in the value. We for this case our depth should be -1, right? Because it is in the next layer, right? And we'll have if node dot right down equal to none. Then we'll have DFS node dot right value in depth -1. Also, we can change this to Python code, right? So we have DFS, right? So this is DFS. So instead of using Q, right? We are going to say if depth equals 1, right? Then we are going to have create a left node equals new tree not new, it's Python tree node value, and right node equals tree node value, right? And we'll have L node dot left equals node dot left, right? And we'll have node dot left equals L node. Here we cannot have the order matters, right? We should have this left pointing to this node to left first, and have the node left pointing to the new node left. Otherwise, we can not find the nodes dot left anymore, right? And also we have right node dot right equals node dot right. And also we have there's no semicolon. This is also node dot right equals new node right node. So this is termination condition. So we'll say else, right? Else. Else if this node to the left is not empty, right? We just DFS node dot left and value and depth minus 1, right? And we'll also have if node node dot right is not empty, right? So I have DFS node dot right value depth minus 1. Okay. It is ON because we need traverse the whole tree, so it will be ON time complexity.